Hello students, we are studying about bigger method. We have solved several problems in different cases which have no solution, unbounded solution and having a solution. Now we are going to solve system of linear equations using bigger method. Earlier we have solved system of linear equations using two-phase simplex method. Comparing the two, I say that the two-phase method is easy to solve linear equations because while using two-phase simplex method for solving linear equations, we have to write only phase 1. We cannot go to phase 2. After phase 1, we obtain the solution. Therefore, it is easy to solve system of linear equations using two-phase simplex method, but phase 1 of two-phase simplex method. But if you are given the instruction, solve the linear equations using bigger method, you have to use bigger method itself. So we can see a problem of solving linear equations using bigger method. Consider the system of equations x1 minus x3 plus 4x4 equal to 3. Then 2x1 minus x2 equal to 3. 3x1, third equation in the system, 3x1 minus 2x2 minus x4 equal to 1, and x1, x2, x3, x4 greater than or equal to 0. There are 4 variables in the equation, and in several equations some of the variables are absent. Therefore, be careful while writing the coefficients in the table. First, we have to write the modified problem. To solve using bigger method, first of all, we have to write the modified problem. In the modified problem, we have a modified objective function, and we have to minimize that modified objective function, and we call the objective function as capital F. Minimize f equal to small f, the original objective function with the minimization form. But here we have the system of equations. There is no such function. Then sum of m into sum of the artificial variables. Therefore, we put minimize capital F equal to f in the position 0 ആണ്, small f in the position m into sum of the artificial variables. We can see the artificial variables later, and we can fill the position of the artificial variables here. Subject to the conditions x1 ഇനി തെറ്റാതിരിക്കാൻ നമുക്ക് x2 ന് പൊസിഷൻ ഇട്ടേക്കാം minus x3 plus 4x4. Already this is an equality, therefore no need of surplus or slack, only artificial variable, plus x5, the artificial variable, equal to 3. Then second equation 2x1, then minus x2, no x3, x minus x2 here. In the position of x2 we can write x2. We have reserved positions for x1, x2 and x3. So 2x1 minus x2 here. x3, x4 illa. Plus artificial variable x6 equal to 3 again. Then third equation 3x1 minus 2x2, then no x3 minus x4 plus an artificial variable x7 equal to 1. x1 etc. x7 greater than or equal to 0. And which are the artificial variables? x1 to x4 are given, x5, x6 and x7. All the three newly introduced variables are artificial variables. These are all artificial variables. Then we can fill the objective function as m into sum of the artificial variables, m into x5 plus x6 plus x7 എന്ന ആ പൊസിഷനിൽ നമുക്ക് fill ചെയ്യും. Now we are going to solve the problem using bigger method. Bigger method apply ചെയ്തിട്ടാണ് നമ്മൾ ഈ പ്രോബ്ലം ഇപ്പോൾ സോൾവ് ചെയ്യുക. ഫേസ് ഓൺ ഉപയോഗിച്ച് ചെയ്യാം. അപ്പോൾ വ്യത്യാസം നിങ്ങൾക്ക് വേണമെങ്കിൽ ഇപ്പം അങ്ങ് പറഞ്ഞു തന്നേക്കാം. എന്തായിരിക്കും വ്യത്യാസം? ഇക്വേഷൻസ് സിമിലർ ആയിരിക്കും. ഇവിടെ വരുന്ന വ്യത്യാസം സം ഓഫ് ദ ആർട്ടിഫിഷ്യൽ എം ഇൻഡു ഇല്ല, സം ഓഫ് ദ ആർട്ടിഫിഷ്യൽ വേരിയബിൾസ്. മിനിമൈസ് ഫേസ് 1 മാത്രമേ ഉള്ളൂ, ഫേസ് 2 ഇല്ല. മിനിമൈസ് So x5 plus x6 plus x7 എന്നുള്ളതായിരിക്കും ഓക്സിലറി ഒബ്ജക്റ്റീവ് ഫംഗ്ഷൻ. ആ ഫേസ് കൊണ്ട് തീരും. അപ്പോൾ ഈ എമ്മിൻ്റെ കോംപ്ലിക്കേഷൻസ് ഒന്നും ഇല്ല. ഫേസ് കൊണ്ടാണ് ഒരു കണക്കിന് കൂടുതൽ എളുപ്പം എന്ന് ഞാൻ പറയും. ബിഗം ഉപയോഗിക്കാം. സോൾവ് യൂസിങ് ബിഗം എന്ന് പറഞ്ഞാൽ അത് ഉപയോഗിച്ചേ മതിയാവും. അതുകൊണ്ട് നമുക്ക് അത് ഉപയോഗിച്ച് തന്നെ അങ്ങ് ചെയ്തേക്കാം. ദെൻ വി ഹാവ് ടു റൈറ്റ് ദ ടേബിൾസ്. ടേബിളിൽ വേണ്ടത് ബേസിസ് B, P1, P2, P3, P4 and for the artificial variables P5, P6 and P7. And we have to write the coefficients from the modified objective function. Original objective function system ആയതുകൊണ്ടില്ല. അപ്പോൾ P1, P2, P3, P4 ന് 0. For the artificial variables P5, P6, P7 M എന്നുള്ള values എടുക്കാം. Then the basic variables are the artificial variables x5, x6 and x7. x5, x6, x7. Coefficients all are artificial variables. Bigger method എല്ലാത്തിൻ്റെയും കോയിഫിഷ്യൻസ് ക്യാപിറ്റൽ M എന്നാവും. B values basis B വെച്ചാണ് നമ്മൾ സെപ്പറേറ്റ് ചെയ്യുക. B values here 3, 3, 1 അല്ലേ? 3, 3, 1. From the first equation 1, x2 is 0, minus 1, then 4, then 1, 0, 0. From the second equation we get 2, minus 1. The other next two coefficients are zeros, then 0, 1, 0. From the last equation 3, minus 2, x3 is absent 0, x4 minus 1, 0, 0, 1. Then we have to find the net evaluations. Net evaluations. First we have to write capital F equal to 3, m into 3, m into 3, m into 1 sum. 7m എന്ന് കിട്ടും. 7m. ഇപ്പോൾ അതിനൊന്നും പ്രാധാന്യമില്ല, കാൽക്കുലേറ്റ് ചെയ്തില്ലെങ്കിൽ പോലും പ്രശ്നമില്ല. Then we have to find the net evaluations. 0, minus m, minus 2m, minus 3m. 3, 2, 5, 1, 6. Minus 6m എന്നായിരിക്കും ആദ്യത്തെ net evaluations. Net evaluation. Then 0, say m into 0, m into minus 1, m into minus 2. അപ്പോൾ അതിൻ്റെ ഓപ്പോസിറ്റ് സൈൻ 0 മൈനസ് ഓഫ് എന്നാണ്. അപ്പോൾ അത് 3m എന്നാവും. m into minus 1 ഒരു മൈനസ് സൈനും കൂടെ വരുമ്പോൾ അത് m, ഇത് 2m, m plus 2m 3m. Then corresponding to P3 0 minus of m into minus 1. Then m into 0, m into 0. m into minus 1 into negative, that is plus m. Again for P4 0 minus of m into 4, m into 0, m into minus 1. Minus of minus 4m plus m, that is minus 3m. Then all the others are basic variables. You know that the net evaluations are zeros. No need of calculation. Then least. M is a very large positive quantity. Then comparing the coefficients, minus 6m and minus 3m are negative. Comparing the coefficients, you can see that minus 6m is the least. Then B by P1 values. B by PI എന്നൊരു കോളവും കൂടെ നമുക്ക് ആവശ്യമുണ്ടായിരുന്നു. B by PI values. B by P1 here. B by P1 values. 3 by 1 is 3. 3 by 2 next one. Then 1 by 3. Least one is 1 by 3. And we select corresponding element in the first column. Then what happens? X7 goes out of the basis and X1 comes into the basis. X7 is an artificial variable and the method of procedure of bigger method ensures that it will never re-enter the basis. Therefore we cut to the column of x7, that is p7. p7 ini ചെയ്യേണ്ട ആവശ്യമില്ല. Then the changes in the basis x5, x6, x7 goes out of the basis and x1 comes into the basis. Then correspondingly we can do the calculations. x5 in m, x6 in m, x1 into coefficient is 0. Then the 3 can be made 1 by dividing with the 3 all the coefficients in the last row. Then this will be 1 by 3. This is 1. Again minus 2 by 3. 0. Minus 1 by 3. 0. 0. P7 നമുക്ക് ആവശ്യമില്ല, ഇത്ര മതി. Then we move to the first row. First row യിൽ 1 ആണ് കാണുന്നത്. പുതിയ റോയുമായിട്ട് സബ്ട്രാക്ഷൻ നടത്തിയാൽ മതി. R1 goes to R1 minus new R3. പുതിയ R3 സബ്ട്രാക്ട് ചെയ്താൽ മതി. 3 minus 1 by 3. 3 into 3, 9 minus 1, 8 by 3 അല്ലേ? 8 by 3. Then 1 minus 1, 0. 0 minus 2 by 3, that is 2 by 3. Minus 1 minus 0. 4 minus 1 by 3. 4 plus 1 by 3. 4 into 3, 12 plus 1, 13 by 3. എന്നാണ്. 1 minus 0. 0 minus 0. Then for the second row, we have to multiply the new R3 with 2 and subtract. 3 minus 2 by 3. 9 minus 2. That is 7 by 3. 2 minus 2, 0. Minus 1. Minus minus plus 4 by 3. Minus 1 plus 4 by 3. That is 1 by 3. Then 0 minus 0. Again 0 minus 2 into minus 1 by 3. That is 2 by 3. 0 minus 0. Then 1 minus 0. That table is also completed. Then we have to find the net evaluations. Find the net evaluations. Capital F equal to, കണ്ടുപിടിച്ചില്ലേ പോലും കുഴപ്പമില്ല, 8 by 3 m plus 7 by 3 m plus 0 into 1 by 3. 15 by 3, that is 5. You can write it as 5m. 3 into 5. 5m എന്ന് കൊടുക്കാം. x1 in the basis, x5, x6 in the basis. Corresponding net evaluations are zeros. Then we calculate corresponding to P2. 0 minus 2m by 3 minus m by 3. Next one is 0. 2 plus 1, 3 by 3 negative minus m എന്ന് കിട്ടും. Next one 0 plus m. 0 minus 13m by 3 minus 2m by 3. Next is 0. Minus 15m divided by 3. That is minus 5m. Minus 5m. There are two negatives, minus m and minus 5m. Comparing the coefficients, you can see that minus 5m is the least. Then b by p4. Evaluate b by p4 values. b by p4, that is 8 by 3 by 13 by 3. 8 by 13. Then 7 by 2. Then 1 by 3 by minus 1 by 3, which is negative. You calculate the least value as 8 by 13. Therefore, we select 13 by 3. Now, x4 comes into the basis in the position of x5. x5 goes out of the basis. x5 was an artificial variables. Therefore, we can leave the column of x5 here. Order lalla x6 avade edakku remain cheyum. x5 povunu. Basis is x5 goes out of the basis and x4 enters the basis. Then x6, then x1. Original variables were x1, x2, x3 and x4. x4 coefficient 0 ആയിരിക്കും. x6 ഒരു m, x1 0. Then in order to make this 13 by 3, 1 multiply with 3 by 13. Then this value will be, b value will be 8 by 13. Next 0. 2 by 3 into 3 by 13. 2 by 13. This is minus 3 by 13. This is 1. Then here a 0 in the column of P6. Here P5 and P7 are absent. Not that point. Then we have to make this value 2 by 3 0. Multiply this element with the 2 by 3. The elements of the new R1 by 2 by 3 and subtract from the second row. Second row il ആവശ്യമുള്ള elements എടുത്ത് എഴുതിയാൽ നല്ലതായിരിക്കും. നമുക്ക് ഇവിടെ എടുത്ത് എഴുതാം. 7 by 3, then 0, then 1 by 3, then 0, then 2 by 3. അടുത്ത പൊസിഷനിൽ 0 വേണ്ട, അത് കഴിഞ്ഞിട്ട് 1. ഈ 0 എഴുതിയിട്ടില്ല. 0, 1. Then multiply the elements of the new R1 with the 2 by 3 and do the subtractions. 2 by 3 on 8 by 13 into 2 by 3. 8 by 13 into and 16 by 3 into